Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm Anna.
And I'm Avery. Today's Tuesday, January 27th, 2026, and we've got some fascinating stories lined up for you.
We certainly do. On today's episode, we're diving into NASA's groundbreaking new dark matter map, getting the latest updates on this week's orbital launch schedule, and learning about what the Artemis II crew might see on the far side of the moon.
Plus, we'll explore stunning new insights into Jupiter's complex cloud systems, find out about a rare solar eclipse that only a handful of people will witness, and get the latest on SpaceX's upgraded Starship development.
Let's get started.
Take it away, Anna.
Our top story today comes from NASA's Jet Propulsion Laboratory, where scientists have created one of the most detailed dark matter maps ever produced, using data from the James Webb Space Telescope.
This is really exciting stuff, Anna. The map shows how dark matter, that invisible, ghostly material that makes up most of the universe's mass, overlaps and intertwines with regular matter, like stars and galaxies.
Published Monday in Nature Astronomy, this map is twice as sharp as any previous dark matter map made by other observatories. Diana Scogniaglio, the lead author and astrophysicist at JPL, described it as seeing the invisible scaffolding of the universe in stunning detail for the first time.
What's particularly fascinating is how the map confirms that dark matter and regular matter have essentially grown up together. Wherever you see a massive cluster of thousands of galaxies, there's an equally massive amount of dark matter in the same place. When you see strings of regular matter connecting clusters, dark matter strings are there too.
The team used Webb's unprecedented sensitivity to observe nearly 800,000 galaxies in a region of sky about 2.5 times larger than the full moon. They detected dark matter by observing how its mass curves space itself, which bends light from distant galaxies as it travels to Earth.
Here's something to ponder. Without dark matter, we might not even be here. Dark matter began clumping together first in the early universe, and those clumps then pulled regular matter together, creating the conditions for stars and galaxies to form earlier than they would have otherwise.
That earlier star formation was crucial because those first generations of stars turned hydrogen and helium into the rich array of elements that now make up planets like Earth. So in a very real sense, dark matter influenced the creation of the elements necessary for life.
Looking ahead, the upcoming Nancy Grace Roman Space Telescope will map dark matter over an area 4,400 times bigger than this Webb study, though it won't match Webb's incredible resolution. For even more detailed looks, we'll have to wait for next-generation telescopes like the proposed Habitable Worlds Observatory.
Fascinating research that's literally revealing the invisible foundation of our universe.
Moving on to this week's launch schedule, it's shaping up to be a busy last week of January with flights from Florida, California, and New Zealand on the manifest.
That's right. SpaceX is planning to close out the month with the GPS-3 SV09 mission, along with up to 3 Starlink launches. The GPS launch is scheduled for late Monday evening from Cape Canaveral.
The GPS-3 SV09 satellite, named Ellison Onizuka after one of the fallen Challenger astronauts, will be launched to medium Earth orbit. This spacecraft offers improved accuracy and jamming resistance over previous versions of GPS.
Meanwhile, Rocket Lab's Electron is preparing for the Bridging the Swarm mission from New Zealand's Mahia Peninsula on Wednesday. This launch will carry South Korea's NEONSat-1A observation satellite to sun-synchronous orbit.
The NEONSat constellation is designed to provide near real-time disaster monitoring capability for the Korean peninsula. The 100-kilogram NEONSat-1A features a high-resolution optical camera and will join an existing NEONSat satellite already in orbit.
This mission has already faced a couple of delays. It was originally scheduled to launch back in December, but was scrubbed after sensor issues during countdown.
SpaceX also has multiple Starlink missions on the schedule this week from both coasts. Group 17-19 from Vandenberg Space Force Base in California on Thursday, and Group 6-101 from Cape Canaveral later that same day.
And looking ahead to early February, the first Starlink mission of next month, Group 6-103, is currently scheduled for Sunday, February 1st.
China also has two possible flights on the manifest, a Changzheng 7A from Hainan Island and a Geelong 3 from the South China Sea, though neither has a confirmed launch date yet.
It's worth noting that China's year in spaceflight has already been eventful, with 2 launch failures within 12 hours in mid-January, so they may be proceeding cautiously with these upcoming missions. Okay, moving on. Our next story takes us to preparations for NASA's Artemis II mission, where 4 astronauts are training to become the first humans to see parts of the moon that have remained hidden from view, even during the Apollo missions.
The Artemis II crew, Reed Weissman, Victor Glover, Christina Hammock-Koch, and Jeremy Hansen, won't land on the lunar surface, but they'll fly around the far side of the moon and potentially observe regions never before seen by human eyes.
Among the most significant targets is Mare Oriental, a vast 600-mile wide impact basin that sits along the edge of the lunar far side. Its location makes it nearly impossible to view from Earth, despite its massive scale.
The crew will spend a dedicated 3-hour segment of their mission focusing on direct lunar observation. NASA exploration scientist Jacob Bleacher emphasizes that human vision can detect subtle surface differences, variations in brightness or texture that indicate differences in rock composition and geological age.
What's fascinating is that the astronauts have been training extensively in geology, including simulated exercises in Iceland, where they practiced identifying volcanic and impact-related features in environments resembling the moon.
The far side of the moon holds a geologic record less disturbed than the near side. While much of the near side is covered with maria, vast plains of ancient lava that have erased older surface features, the far side remains heavily cratered and relatively intact.
Because of tidal locking, the moon always shows the same face to Earth. Until the Soviet Luna 3 mission in 1959, no one had any idea what the far side looked like. Even the Apollo missions only had brief views and poor lighting.
Artemis II breaks that pattern by taking advantage of a launch window and flight path that ensures better visibility of the hidden hemisphere. The mission is currently scheduled for no earlier than February 6th.
And astronaut Christina Koch noted that the mission may help shift public understanding away from the outdated phrase, the dark side of the moon, which falsely implies the region lacks sunlight.
An exciting mission that will give us unprecedented views of lunar territory that remained largely mysterious for all of human history.
Now let's turn our attention to Jupiter, where NASA's Juno spacecraft continues to reveal the gas giant's secrets from beneath its dense cloud layers.
Juno has been orbiting Jupiter since 2016, peering through storms and cyclones to unveil the planet's hidden complexity. And recent observations are showing just how much more intricate Jupiter is than we ever imagined.
One of the most fundamental questions scientists have debated for decades is how deep Jupiter's distinctive cloud bands actually go. By measuring Jupiter's gravity field, Juno discovered that these belts and zones, which are alternating east and west flowing jet streams, extend about 1,900 miles, or 3,000 kilometers below the cloud tops.
That's incredible depth. And Juno's discoveries have completely upended our understanding of Jupiter's interior structure too. Scientists long thought Jupiter had a small, solid core surrounded by hydrogen and helium. But Juno's data suggests the planet has a larger, more diluted core than previously believed.
The spacecraft has also provided the first detailed views of Jupiter's North Pole, revealing massive cyclonic storms arranged in fascinating patterns. 8 storms in an octagonal pattern in the north and 5 in a pentagonal pattern in the south. These storms are extremely resilient and have persisted for years.
And here's something really intriguing. Juno recently captured images showing a mysterious green glow near Jupiter's North Pole. The flash of light was traveling at breakneck speed, which makes capturing it even more remarkable.
Scientists believe this could be lightning, but Jupiter's lightning is vastly different from Earth's. It's caused by clouds containing ammonia water solution and can be much more powerful than terrestrial lightning.
Juno's mission has been extended multiple times and was scheduled to end in September 2025.
but appears to still be operational with no new end date being promoted. During this extended phase, the spacecraft is conducting close flybys of Jupiter's intriguing Galilean moons, Ganymede, Europa, and Io.
Eventually, Juno will meet its end by burning up in Jupiter's atmosphere, but until then, it continues to revolutionize our understanding of the solar system's largest planet.
Our next story involves a celestial event that very few people will witness. A rare annular solar eclipse set to occur over one of the most remote places on Earth.
On February 17, 2026, a spectacular ring of fire eclipse will be visible from a narrow stretch of Antarctica. The phenomenon will only be fully visible from an uninhabited region of the continent, with just 2 research stations falling within the event's path.
The antumbral shadow of the moon, the area where the full annular eclipse can be seen, will travel across a 2,661-mile stretch of mainland Antarctica. Only 2 inhabited locations fall within this narrow band: Concordia Station, a French-Italian base, and Mirny Station, operated by Russia.
At Concordia, annularity will last 2 minutes and 1 second, with the sun positioned 5 degrees above the horizon. At Mirny, it will experience 1 minute and 52 seconds of annularity, with the sun slightly higher at 10 degrees.
Given the extreme location and limited infrastructure, eclipse meteorologist Jay Anderson noted that it's a challenge to reach, and neither of the 2 inhabited locations is set up to welcome tourists.
However, a partial eclipse will be visible over a much larger region, including several Antarctic research bases, parts of southeastern Africa, the southern tip of South America, and stretches of the Pacific, Atlantic, and Indian Oceans.
For example, Poland's A.B. Dobrolansky Station will see 92% of the sun covered, while McMurdo Station in the U.S. will see 86%. Even distant cities like Durban in South Africa will witness about 16% coverage.
Weather could be a significant factor, though. Mirny Station averages 65% cloud cover in February, while Concordia has a clearer profile with about 35% coverage. And temperatures can drop as low as minus 112 degrees Fahrenheit.
Interestingly, the eclipse itself might improve viewing conditions. The sudden temperature drop from the eclipse can disrupt local cloud formation, potentially causing convective clouds to dissipate.
Though, if you're one of the handful of researchers stationed in Antarctica next month, you might be in for a spectacular show, assuming the clouds cooperate and you can brave the extreme cold. And finally, in some late-breaking news, we have an update on SpaceX's Starship development program.
According to a post from CEO Elon Musk, the delayed first test of SpaceX's upgraded Starship rocket, version 3, is now slated for mid-March.
This 3rd version of Starship is larger and more powerful than previous iterations. Crucially, SpaceX plans to use Starship V3 to launch its next-generation Starlink satellites, which will be capable of faster data speeds but are heavier and larger.
It's also the first version designed to dock with other Starships in Earth orbit, a capability the company needs to reach the Moon or Mars. This comes as SpaceX faces pressure from the Trump administration to return U.S. astronauts to the lunar surface before the end of his second term.
SpaceX was making progress toward a launch of Starship V3 in late 2025, but in November, the booster stage suffered a major explosion during testing that blew out an entire side of the steel rocket.
The company said it was performing gas system pressure testing when the explosion happened, but hasn't offered a more detailed breakdown of what went wrong.
The second version of Starship was a mixed bag. The program successfully reached orbit, deployed dummy versions of next-generation Starlink satellites, and caught multiple booster stages after they returned to the launch pad.
But Starship V2 also suffered several explosions and setbacks. Some resulted from SpaceX's developmental approach of pushing test vehicles to or past their limits. Others were more unexpected, like when a Starship vehicle erupted in a massive fireball during ground testing last June.
Meanwhile, competition is emerging. Jeff Bezos's New Glenn rocket successfully launched for the first time in January 2025, and completed its first booster landing in November. Blue Origin is planning a third New Glenn launch in late February.
And late last year, Blue Origin revealed it's developing a larger, super heavy variant of New Glenn, which more directly competes with Starship.
So, while SpaceX continues to dominate the global launch market, other players are starting to close the gap. It'll be interesting to see how the Starship V3 test goes in March.
And that wraps up today's episode of Astronomy Daily.
Thanks for joining us for another journey through the cosmos. Remember to check out our website at astronomydaily.io for more space and astronomy news.
And don't forget to follow us on social media at Astro Daily Pod for updates between episodes.
Until next time, keep looking up.
Clear skies, everyone.
Astronomy.